Okay, so in this problem, we're told that three high school juniors, Reese, Matthew, and Chris, are running for student council president. The survey is taken a week before the election, asking a total of 40 students. So they tell you how many students there are. There are 40 students. Which candidate they will vote for in the election. The results are shown on the table below. So here's the survey, right? And the candidates' names and the number of students supporting each candidate. And Reese has 15 students, Matthew has 13, and Chris has 12. You don't need to add these up because we know 40 students were surveyed. They told us that. The question is saying, based on this table, what is the probability that a student will vote for Reese? Here what they're really asking is about experimental probability, which means based on the survey, and this entire survey right here, and that's what we're using as our source, how likely is it that a certain event will happen? So in this case, we're looking at Reese. So probability for an experiment, you have a total number of trials in your denominator, and that's 40 right here. That's the total, right? And in the numerator, we'll have the number of successes. In other words, the number of things that we're looking for that actually happen. So we're looking for Reese, right? The probability of Reese being elected. So every time we see Reese get a number, or in this case a student supporting him, then we can add that here to the numerator. So since 15 students support him, the probability is 15 out of 40, right? It's the number of successes, which depends on what you're looking for, but in this case, success means, okay, Reese was chosen, is 15 out of 40. And if we reduce that fraction, what do we get? Well, 5 goes into 15 3 times, goes into 40 8 times. So the answer here is 3 out of 8. All right, hope that helps.